Good morning, dear students. Good morning. How are you all? Fine. Okay, dear students. So, this is a video of class 9, and in this video, we are going to talk about one of the most important topic, and that one is fractional distillation of air. Okay, now. So we know that in the atmosphere air is there, and air is a mixture of many gases like nitrogen, oxygen, argon, carbon dioxide, water vapor, and other moistures, dust, water vapor are also present. Okay, now, and we have to separate all these mixers into the different components, into the different gases by the fractional distillation of air. Okay, now, so how will we actually separate that one? We will actually use the technique, and that one is fractional distillation. This is one of the method by which we can separate all the constituent of air, so all the component of air. Okay, now you can see that the percentage of gases into the air is actually varies, and they have different boiling point, and on the basis of different boiling points we can actually separate that air. But here one point is there: air is gases and boiling point is there. So first of all we have to convert this air into the liquid form. Okay, now, and then after we will actually use various processes to separate the air by the fractional distillation. Okay, now, then you can see in the second slide, this one the gases are there, and here it is written the gases, these gases are there: nitrogen, oxygen, argon. Percentage composition into the atmosphere you all know. Okay, now, from your junior section, from the junior classes, you know that 78%, 21%, then 0.93% of argon is there. Here boiling point is there: highest boiling point minus 183 degrees C is for oxygen, lowest for nitrogen, and then argon it is given. So you should remember this one also, it is very important as per your exam point of view. Okay, now, so we have to actually do, one by one we have to separate all the components of air by first of all converting this into the liquid form, and then after at its boiling point you have to convert this air into the different components: nitrogen, oxygen, and argon. Okay, now, here you can see it is written separation can be done by the process of fractional distillation of air. Okay, now, so what is the fractional distillation of air we will actually do in one of the diagram. Okay, now we will see, and then after we will discuss all its essential points. So here you can see this is the diagram what has been taken from the Cordova publications. Okay, now this is actually given in that book. Here you can see that filter is there. First of all, filter means air will enter into the filter, and here the air will remove the dust and the moisture. Okay, now that air will filter, that one air will filter by the filter, and all the dust and moisture will be removed in the filter, and then air will in, and it will go into the compressor. This one is compressor, and compressor means you will, this one is movable, this one is movable. Okay, now air when pass through this one, it will move and it will compress the particle of air, so air will become hot. Okay, now during the compression what will happen, the particles of air will collide, the particles of air will collide, and during the collision they will face some warmness, and okay, now the air will become hot. So here it is written hot air, here it is written hot air. Okay, now air will enter into this big uh, chamber, where through this concentric pipes we are actually putting and giving freezing cold water. What is the meaning of that freezing cold water? That means we are actually giving this freezing cold water that if hot air will enter into this big chamber, then what will happen, that hot air will feel relaxed, its particle will not move here and there, its particle will stop at one place. That means kinetic energy will stop, and if the kinetic energy will become less, stop not, kinetic energy will become less, the particle will stop, and if the particle will stop, that is trying to change into the liquid form, because I have told earlier that air, first of all, it will convert this into the liquid form. So in this big chamber you can see that here at the downside the freezing cold water in is there, and here that when it will go into this one, into this chamber, the hot air is there na. So hot air, that means when it will pass, hot air is there, that means it will change into the liquid form, and freezing cold water after becomes hot, it will go outside. Again and again we will put the give the freezing cold water, and water will become hot and water will go outside. So this is the thing you should know. Now your hot water becomes cold. Now cold compressed air will go into the separator, and what will happen into the separator, separate in the separator carbon dioxide out as dry ice, carbon dioxide out as dry ice in the separator. If some of the thing is present in the cold compressed air, that one is carbon dioxide, and that carbon dioxide will separate from this. Okay now, so you have understood. Now set to the from the separator, that all the carbon dioxide has passed, came out, and your air became liquid air. Now liquid air expansion jet, what is the meaning of expansion jet? Expansion jet will give the amount of time to the cold compressed air that the particles will go away from one another, and if the particles will go away from one another, that means this is liquid air. Expansion means what? Expansion means it will give a space to the cold compressed air. Okay now, so it will transfer into the liquid air. Now liquid air will go into the fractional distillation column, and here you know dear student, in the fractional distillation column, what will happen, on the basis of its boiling, on the basis of its different in boiling point, the gases, liquid form of gases, one by one it will boil. Okay now, first of all nitrogen gas will out. Okay now, as it has, you have seen, minus 196 degree C temperature was there, boiling point was there, so it will come first of all, then after argon, and then after oxygen is here written. Okay now, here it at the bottom oxygen, so you will put this into one of the container. So with this we can say all of that can be separated by this whole of the apparatus, fractional distillation of air, all the apparatus has been set up, and you can see this one. So here, that all the thing we have actually discussed here, the first of all the air is filtered to remove dust and moisture, then after the air is compressed and then cooled to remove carbon dioxide, here it is written. Okay now, so all the thing you should know. Then after this, all the explanation is there. Compressed air is allowed to reach the expansion column through the jet. It is essential, through the jet it will pass where it gets expanded. Okay now, this expansion causes even more cooling. Expansion means hotness is removing. If hotness is removing, that cooling is increasing, and if the cooling will increasing, that means ultimately the air gets converted into liquid state. Okay now, this liquid air is not fed into distillation column, and through its lower side and left there to be warmed slowly, and during this warming process the liquid nitrogen boils at minus 196 degrees C. That means nitrogen gas collected at the top part of the fractionating column. It is essential that top part of the fractionating column. Okay now, and then after argon will reach at its boiling point at minus 186 degrees C, and then after it can be separated. Then after, this is the time of separation of this liquid oxygen, and which has highest boiling point, and that one is minus 183 degrees C, and that can be separated at last time. Okay now, So the oxygen gas boils off last and collected at the bottom of the fractionating column. So this is all the process. We will make picture in the class and we will do it directly. Okay now. So this is the fractional distillation of air, and I hope you have understood. Thank you, dear students.